Okay, so we'll solve some questions of very high quality, very high level questions, and how to think of solving problems. What are the ways or approach to think about it? Let us try that. There is one good question. They have given. There is one question. Let us think about it. So they are saying that two men move identical heavy boxes. There are two identical boxes. One box is kept like this. Another case, same box, same surface, same box, same surface. But one person, two men move identical boxes. One person is applying a force like this way at an angle theta with the horizontal. Other person try to apply force F this way at an angle theta to the horizontal. Two men move identical heavy boxes through equal distances on a horizontal floor, not frictionless. Not frictionless means there is a friction here. The surface is a rough surface. In both cases, this is the rough surface. First man is pushing. I think this is the first case. The man is pushing. So this is push and this is pull, right? These are two cases. One is push and the other is pull. Okay, so the question is the first man is pushing while second is pulling the box with equal forces of equal magnitude. Magnitudes are FF, angles are different. Theta is this side. Question is both the men deliver equal power. So there are some statements given. I will write the statement. Block has same mass, okay, same mass mm. First statement is both men deliver equal power. Second statement is both men do equal amount of work. Third case, third statement. First man is what? This is the first man. Okay, so some man here may be starting. This is the first man. First man is pushing, and here second man may be here like this. He will be pulling. This is the second man. Okay. So first man does more work than the second man. Fourth statement is first man delivers more power than the second man. The last statement is second man delivers more power than the first man. These are some statements, and it is given an important condition. What is given here is both the blocks move. The first man is pushing, second man is pulling the block equal. So equal distances. So both the blocks are moving equal distances. Suppose you take delta R displacement. Equal displacement is there. Okay, angles are also same. I think they are same angle, same force, but one is pushing, another is pulling. Same displacement is happening. Surface is rough surface in both cases. Identical bodies are there. So these are the statements which we have to now choose which of them are correct. We have to choose More than one possibility is also there. More than one possibility means more than one statements can be also correct. So what do you think now? All of you can try this question. It's a good question. Very, very fundamental concept is involved in this question. Anybody else is here to join? Please inform them to join. Question is clear. All of you are clear about the question. Question is clear. Again, I will repeat. So there is a block. Okay, this is a block. Let us say this is a block. Same block is kept on the same surface. At one time, a man is pushing it. He is applying a force F at an angle theta. Another case, second man is pulling it by applying a force like this. And in both the cases, surfaces are rough and blocks are moving same displacement. The displacement in both cases same. So they are asking to compare. What are they asking to compare? First of all, work is there. Work done by first man, work done by second man. Second thing is that power delivered. Power delivered by the first man in pushing and power delivered by the second man in pulling. So two things we have to compare, work and power. Okay. So let us calculate that. Hmm. Hmm. Equal work. That means we're saying option means second statements are correct. Second statement is correct. Right? Second statement is correct. Anything else? I wish second man delivers more power. Second man delivers more power than the first man. 5. First man does more work than second man. Work. They are not asking force. Work. No. Why? No. You are saying correct, but why means you are saying pushing is more. Pulling is which is easier? You are saying. Arjun? Pulling is easier. Why? What is the reason for that? Right. Just check the notes. Why I have told it is easier? No. Not that. It is related to friction. Friction is more and friction is less in some cases. Check. Tell me which case friction is more and less. Which case friction is more or which case friction is less? Yes, I agree. Which case friction is more friction? I will again repeat this question. It's the first question we are solving. So two blocks are there, identical block, same surface, rough surface. First case, man is pushing, same angle, same force. Second man is pulling, same force, same angle. And in both the cases, displacement is happening same. We have to choose which of these statements are correct. So first statement is both men deliver equal power. So in both cases, power is same. Second statement, both men do equal amount of work, same amount of work is there. Third case, first man does more work done by first case is more than second case. First man delivers more power is that second delivers more. So two things is there. They are asking to compare work and power. Work done by the man in first case and second case, you calculate work done and calculate power. Power due to the first man and second man. Both the things you have to do. No, no, the more and pushing, pulling. Can you tell me what is the reason why you said now pulling is easier than pushing? That topic you have studied. What is the reason for that? Can you recall? Normal changes. Normal is same way, but in friction, in one case, yeah, normal one case is upward and one case normal is down. Means normal increases. Ah, extra one case it becomes larger, one case it becomes smaller. So due to that, friction only changes now. Friction only changes. Hmm. No, no, no. Force, same force is applied here. External force applied by man is the same in both cases. Constant force in both case constant force it is. We have to we have to find which of them are correct. Maybe more than one is correct. Hmm. Second and third. Okay. Why? Why do you think second and third is? Hmm. Same force magnitude, same displacement. Angle is also same. Angle is also same. Ah, that is why work done has to be same. Right. So if you see here, work done. Yeah, first see here. First see here. First see here. This is the mass. In case of pushing, the man is applying a force like this way. This is the directional force. This is pushing. And this force is making angle theta with the horizontal means this is the angle theta. Either you show this way or that way, same thing. Now displacement is happening here. This is the displacement delta r, right? So dot product you calculate work done in this case of pushing. So magnitude it is force dot displacement, right? So force constant force, displacement is also magnitude and angle is constant. This is the case of pushing. Now case of pulling you see. Then you asked out. In this case, first let us pushing and pulling you see. So pulling means it will be like this way, same force, right? And this displacement is also same delta r. Angle also is the same angle theta. So this is the case of pulling. Now in this case, work done in pulling, dot product of same force, because force is a constant force. So magnitude of force, magnitude of displacement, constant. Now tell me, what is the doubt in this? Work done is friction. No, no, we are not worried of friction. Why are we worried of friction? A rough surface, but why do you want? Do you want to calculate work done by friction? Then no, no, net. Why do you want to calculate the net force? They are not asking to calculate work done by net force. Let us stick to the. Let us focus to what they are asking. They are asking to calculate work done by the man. Man is applying the force. That same force, same. No, no, they have not asked that. Work done by man. Work done by man means work done by the force applied by the man. So that means both are same. That means second option is correct. Means second statement is correct. They are doing both equal work. Okay. What about power? Power also we will check. So for power we need time calculations. Now how will you calculate time? Body has moved the same displacement. How will you calculate the time? Now you tell me time calculation. Raghu, how did you do the calculation of time? Logically you can think. That means now you think because acceleration is produced due to net force. In which case net force will be larger. In whichever case net force is larger, time will be smaller. That is logic. So, yeah, same logic you apply. Pulling case net force will be higher because friction is lower. Friction is lower. So acceleration is so time will be less. So power calculation involves that way you can calculate because power is equal to work by time. Work by time. Work is same, that means power is inversely proportional to time. Now if time is small, power will be more. So in the second case of pulling, the friction is less, so net force is more. Net force is more means acceleration is more. More acceleration means it will take less time. Less time means more power. So that is what it is. That means you can logically you can go that the power in case of pulling is larger than power in case of pushing. So if you go with this logic, it is correct only. So let us check that statement. Second one delivers more power. So that statement is correct. Yes, clear. All of you have understood this. That means we did not do much calculation and we can solve it. Right. Okay, let us go next. Hmm. It's one, right? Okay, okay. I'll explain it again. So see, the two blocks are the question you have understood. Yes, question you have understood. Okay. So let us work done calculation. You see. So in the first case, it is pushing. So this is the direction of force, and this is displacement angle. This angle and this angles are same, either this or this way or this way. So this angle with horizontal is theta, and it's a constant force. So work done is force into this dot product. Constant force, so dot product, then force displacement constant. In case of pulling, force is this way and same displacement and angle same angle theta. Work done again dot product F delta cos theta. So in both cases work done are same. Any doubt in this? No, we are not taking force quantity. We are applying the formula definition. What is the definition of work done? Definition of work done is dot product of force and displacement. Definition: dot product of force and displacement. So force, displacement, cos theta. Here also force dot product, force and displacement, cos, displacement, cos theta. If it is a variable force, then you have to apply integration. But it's a constant force, so we are just applying formula, dot product. Work done the same. Okay. Then power is work by time. In both cases, work is same. So power is inversely proportional to time now. So small time means more power. So in case of pulling, in case of pulling, friction is smaller. The friction is smaller in case of pulling. First of all, you are supposed to know that. If you do not know that, then I will explain this case why in case of pulling friction is less and what is the effect happens. So now you see the force in case of pulling. This is the pulling in case of pulling. So this angle is theta. So resolve the force F cos theta, F sin theta. Resolution you do. And what other forces are acting? Mg is acting and normal is acting. Okay. Friction is of course also acting this way. Friction. And friction formula is we know mu times normal. So first balance vertical forces. What is only moving horizontally? Motion is happening horizontally. So first of all, vertical forces you have to balance. So F sin theta plus normal is equal to mg. So normal becomes mg minus F sin theta. Right? Normal becomes. Now friction become how much? Friction you calculate. Mu times normal. Normal is mg minus F sin theta. This is friction. Okay, we want to find out the net force because body starts moving. There may be a net force. Let us calculate net force. Net force. First, let us do this calculation. Any doubt in this? Raghavan, separate doubt. Let us first complete this. After that, I will put. So net force you calculate. So body is moving this way. It has acceleration this way. So F cos theta is larger than friction. So F cos theta minus friction. So let us calculate. So F cos theta minus friction. I will now substitute. Friction is mu times this mg minus F sin theta. Okay, so let us solve this. You open the bracket and take friction capital F1. So cos theta plus mu sin theta. Open this bracket and do this. Okay, minus mu mg. Okay, this is the net force. And net force is what? Net force is mass into acceleration. So from here, acceleration we can calculate. Acceleration we can calculate. Acceleration will be F by mass you divide cos theta plus mu sin theta minus mu g. I have divided mass. Okay. This is the acceleration in case of what? In case of pulling. This is the case of pulling. So when a person is applying pulling force, this is the acceleration happening. Now based on this acceleration and displacement is delta r, because this is a constant force. Now you can see because everything is constant here. Theta is constant, mu is constant, f is constant, everything is constant. So we can apply the calculation for constant acceleration v equal to u plus at, s is ut plus half at square. Those things we can apply. Let us apply. Let us see that initial velocity is 0. It is started moving. So what is displacement formula? Ut plus half at square apply. Ut plus half at square apply. Now what will happen? Displacement u is anyway 0. So half a t square. Correct. So from here, what will be time? Time you calculate. So 2 times displacement by acceleration under root. This is what is time. Clear? This is the time. So once you got time, let us calculate power. So power is work done by time. In case of pulling, let us calculate in case of pulling. So work done already we have calculated. Work done was F displacement cos theta. Both case work done is same. Time we will substitute root under 2 delta r by 8. So now we can write this as F delta r cos theta root under a by 2 delta r. This is the actual formula for power, right? This is the formula for power. So this is case of pulling. F delta R cos theta, this is same because in pushing also same, 2 delta R is also same in pushing, but acceleration is going to be different in pulling and pushing. So this is acceleration in case of pulling we have calculated. In case of pushing also we need to calculate. So let us calculate for case of pushing. Acceleration calculate. No, acceleration is different, that is why it is changing. Acceleration, so we need to check acceleration in case of pushing. Now you see pushing. Yes. So you have applied a force F, and this is theta, this is F cos theta, this is F sin theta, this is normal, this is mg, this is friction. Here also balance vertical forces. So upward is normal, downward is F sin theta plus mg. So here normal is going to be large. Previously it was mg minus F sin theta minus mg plus. Now it is larger now. So what will be friction? Friction is mu times normal. So mu times F sin theta plus mg. That is friction. Now we got friction. Now similarly calculate net force here also. Calculate net force. So net force will be F cos theta minus friction. F cos theta minus friction. Net force is mass into acceleration. Mass into acceleration. So F cos theta minus friction. Friction is mu times F sin theta plus mg. So F I will take common, cos theta minus mu sin theta minus mu mg and into A. So acceleration is F by m cos theta minus mu sin theta minus mu g. This is the acceleration in case of pushing. Now first to tell me which is larger. Acceleration is only the main factor because this is same, acceleration is the main factor. So in which case this acceleration is case of pushing. Okay. Pushing. So now tell me which acceleration is larger. Here acceleration is F by m cos theta plus mu sin theta minus mg, and here acceleration is cos theta minus mu sin theta. So there is a minus here coming. So where is acceleration more? I think only this term is different, right? It is plus here. So acceleration is more. So if acceleration is more, so power will be more. You can see it is depending on acceleration's root a. Root a, other things are constant. So power is proportional to root of acceleration. Root of acceleration. So because in case of pulling, acceleration is more, so power is more. In case of pushing, acceleration is less, so power is less. Clear? Done. This question is done. Now tell me, Raghavan, what is your doubt? No, in that case, mass factor is different, means we need to do calculations then. After calculating only, we have to get some values and then we have to tell whether, which is larger, which is smaller. But this term is only going to be different. First term is only going to be different, mass is changing. Second term is same only, minus mu g, there also minus mu g here also. So you need to check the calculation of first term, how the first term is affecting. If suppose it is possible to decide, for example, suppose I will write the first term and second term again, because here cos theta plus and this is cos theta minus. Okay, so I will summarize here. So in case of pulling and in case of pushing, acceleration I will write, so F by m cos theta plus mu sin theta minus mu g, and here in this case acceleration is F by m cos theta minus mu sin theta minus mu g. Now suppose if they say that, for example, here this term is anyway larger than that term. Now suppose if they say that this mass, first case, second case, pulling. In case of pulling, this mass is smaller, and in case of pushing, mass is larger. Then smaller this mass, it is going to increase further anyway. and if this is larger, it is going to anyway decrease. So there you can decide. There you can decide. Okay, right? Because everything is same, because power is proportional to acceleration, root of acceleration. So acceleration is the only deciding factor, right? Acceleration is the, and the, yes, suppose for example, if you choose lesser mass here, denominator is less, means this factor will become more. More, this first factor become more means acceleration become more. Suppose if you increase the mass, then denominator increases means this will decrease. So it is going to become smaller. If you change mass both equally, same changes are there, then it's we can decide it, but not always, because we need to see how mass is changing. Yes, clear. Yes, Raghavan, any doubt? Any doubt if you have asked? No. Clear. Force has to be greater than friction, means horizontal component, because horizontal component, which is F cos theta, should be larger than friction, otherwise it cannot move, right? Hmm. Yes, anyone else any doubt in this? Done. Then I hope it is clear. Okay, then let us move next. Next question, let us take next question. A potential energy function is shown in the graph. There is a graph, question number 2, which is showing the potential energy versus x. Potential energy versus x graph. This graph is like this way, this way, and this. Some graph is there. From this graph, what we can know is that this is 1, and this point is 3, and this point is 2, and this point is 7, and this point is 5. Okay. Values are in standard unit, that means energy is in joule, and this is in meters. Straight line. Okay, all the graphs are straight line here. Note that these graphs are straight line. They have given this graph. Now question is, a particle moving in this potential field in the positive direction, it possesses 1 joule of kinetic energy. So particle is moving in this conservative system, and when the particle is at 1 meter, then it has a potential energy of 1 joule. I think that also you can see from the graph. 1 joule to 1 meter. Possesses 1 joule of kinetic. Okay, sorry, kinetic energy, not potential. Kinetic energy we are talking about. So when it is at this position 1 meter, it has a kinetic energy of 1 joule. Potential energy you can figure out here. Also note that this is happening at 1 only. This is the point. So at 1 meter, it has a potential energy of 3 joule. From the graph, we can see that. Where it will reverse its direction of motion. So right now it is going this way. Motion or velocity is in this direction. Question is where will it reverse the direction of motion? Reverse the direction of motion. Where it will reverse the direction? Options are given. X is equal to 1 meter itself. Second option, x is equal to 2 meter. Third option, x is equal to 5 meter. Fourth option, x is equal to 6 meter. Where it is going to reverse direction of motion. Why probably do this proper calculation? Hmm. What? Hmm. See, don't worry about potential energy due to gravitation. This is potential energy of the system changing due to along x-axis motion. Okay, it is not the gravitation potential energy is not changing because it is moving on a horizontal surface, so height is not changing. So we are not talking of gravitation potential. This potential energy is a new kind of potential energy. It changes with position, right? So in this case, we have to think about it. And definitely they have given kinetic energy here. So it is already having some issue. Mass, I think they have not given in the question. Potential energy, for instance, on a particle moving in this potential field in positive x direction, if possesses one joule of kinetic energy at 1 meter, where will it reverse its direction? Mass is not given. This is a very good level of questions, right? Which you will not find in ordinary books. These are Olympiad level questions or tricky questions which may come in advanced level, which will check your fundamental knowledge. Don't use any formula, okay? Just think of concept. Formula is not for J students. J students should think this. Huh? What? Mass. You assume some mass and mass you take. Some mass is there. 5 kg, 10 kg, whatever you want. Assume constant mass. Kinetic energy they have only given. Potential energy from this graph you can find out at one potential energy is 3 because this is the peak of this graph. Corresponding point is 3. So at 1 meter potential energy is 3 joule. That we can calculate. No, there is no such relation. Only thing is that total energy should be constant because there is no other kind of friction forces. Only conservative is there, right? Now only conservative forces are there, so that means energy has to be kept constant. Suppose at 1 meter they are saying now 1 meter kinetic energy is 1 joule, potential 3, the total energy 1 plus 3 4 joule, total energy should remain constant 4 joule. That we can say. What u of x is? Where it is given? Where it is given? Where u of x is? Where? This is a graph. This is a no. This is a graph means here as x changes, potential energy changes. Suppose initially x is 0, so potential energy is 1. As x becomes 1, potential energy becomes 3. Straight line it is increasing. So see, potential energy is increasing. Potential energy increases. Then after this, potential energy decreases. It becomes 0 at 2. And then it goes, increases up to 5 when distance becomes 7. Like this thing is given. Come on, man. Why you are thinking like this? So total energy is constant, na? So potential energy changing, so kinetic energy will also change, na? Why don't you think like this? Total energy is right. Total energy is kinetic energy plus potential energy. Potential energy changing according to this graph, na? So kinetic energy is also changing, right? Both will change. Both will change. So, so here they have given at a one particular 1 meter. At 1 meter, if you see, at x is equal to 1 meter, total energy, and you know total energy should be constant. So total energy is kinetic energy here is 1 joule, and from the graph potential energy is 3 joule. So total is 4 joule. So that means the sum of this kinetic energy plus potential energy will always remain 4 joule. That we now know. But kinetic energy will change, potential energy also will change, but the sum of them is always 4. So according to this graph, potential energy changing. So kinetic energy will also be changing. The sum of them is 4. Mass is not changing, speed is changing. Mass you have to take constant mass, particle. If mass is changing, then they will give in the question. Mass is also changing. How mass is changing? They will give information. They have not given me, so obvious that is mass is constant. See, one idea you think that as you go from 0 to 1 meter, potential energy is increasing, so kinetic energy must be decreasing definitely. After this, potential energy is decreasing, so kinetic energy will be increasing after that. Correct? Kinetic energy. After that, this potential energy is again increasing, so kinetic energy must be decreasing. But you cannot figure out the direction. How will you find direction? Direction of motion we have to figure. Yeah. So what is the formula for force, conservative force and potential energy relationship? Force is equal to minus du by dx minus du. Yes. This is what you have to think about it. So if you see the potential energy here, the slope is positive. The slope is positive. That we can also calculate what is the slope tan theta. We can calculate delta y by delta x. We can calculate. Okay. So force we can calculate, but here slope is positive, so force is negative. That means as this body is going from x equal to 0 to x is equal to 1, force must be acting this way. Force must be acting opposite direction. That's why speed is decreasing, right? Speed is decreasing. Hmm. Speed is decreasing. Then after that, slope has become negative. Negative slope means force is positive. Then after uh, now once it reaches x equal to 1 meter, force comes in this direction now. Force starts acting in this direction, and already it has got a speed, so it will accelerate in that direction, so it will accelerate, accelerate, accelerate. Okay, and then slope will change at 2 meters. So when you think at x is equal to 2 meters, what happens? X is equal to 2 meters. Again, force reverses in direction, right? Force now reverses here. Now force is, values of forces may be different, but from 0 to 1 meter, force is constant because the slope is constant. So retardation is happening, okay, retardation is happening, and then after 1 meter to 2 meter, force and velocity same, so acceleration is happening, and after this again retardation happen. So at 2 meters, definitely its velocity is increasing, so it has got larger velocity now. So now it is going to retard, so after 2 meter only it will stop. I understand it. Because after that it's a constant force retarding, it will stop somewhere after 2. So you can eliminate 1 and first and second option. You have now only 5 and 6. What? No. First you see here. At x is equal, so tell me total energy is 4, right? Total energy is 4. Now tell me at 0, it has some potential energy. How much? 1. There's potential energy 1 joule. You can see the graph. 1. So at 0 meter, what is kinetic energy? Now tell me kinetic energy. Over na? 3 joule. 3 joule. And right now they have given that it is going in this way. They have given that it is at this point it is moving in this way. So previously also it was moving, because right now it is under retardation. So 3 joule has become 1 joule because of a retarding force. Are you understanding? This retarding force also we can calculate it. If you want, you calculate this force. Now tell me, what is the slope of this line? Because this is 3 minus 1, so this will be 2, and this is 1 minus 0, this is 1. So this tan theta or slope, this is 2. So this force is minus 2. Minus 2 means opposite, right? So this force, which is F, is minus 2, means it is opposite, and this is a constant force up to 1 meter. Up to 1 meter. After that, 1 to 2, this slope also you calculate. This slope, of course, it will be negative. This slope you calculate. This is total 3. This is 1, right? This interval is 1. This total interval is 3. Uh, uh. So this slope will be minus 3. Slope will be minus 3. So this force will be minus of minus 3. So this is plus 3 Newton. So now from here to here, force is 3 Newton, plus 3 Newton. Now after this point, after 2 meter you calculate. After 2 meter again you calculate this slope. This you can calculate. This is total 5. This is 5 and this is 7. 7 minus 2, 5. 5 by 5, 1. So here in this case this force is equal to minus of 1. That means minus 1 Newton. Right? This is the force. So after this retarding force of minus 1 means opposite. This way it is acting. Now it is clear. So already 3 joule was there. Retardation is happening. Now it has become 1 joule. Now acceleration is happening. Acceleration is happening. We can also calculate how much is kinetic energy here at 2 meter. 2 meter potential energy has become 0. So everything is kinetic now. Right? Everything is kinetic. So here kinetic means 4 joule. 4 joule. Because potential has become 0 here. 2 joule at 2 meters, right? Potential energy has become 0, graph is become 0. So kinetic energy will be, total energy is 4, so potential is 0 means kinetic is first 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 let us solve this. First let us try this, okay? Then we will see your approach also. So kinetic energy first goes from 3 to 1, then 1 to 4, then it is under retardation. Retardation means now it is going to stop. Now you apply work energy theorem. Work energy theorem, it is going to stop now. So where it will stop, kinetic energy will become 0 wherever it stops. Now from here to here apply work energy theorem. Apply work energy theorem. Let us say that it has moved a distance of x. X displacement, this way it has moved, and force is acting this way. So work done by this force is equal to change of kinetic energy. Right? We are applying after 2. Remember, that's why I told after 2 only it will stop. Okay, before that it is not stopping. So where it will stop, that we want to calculate. So dot product we have to do constant force. So magnitude of force, remember I am writing magnitude, so that should not be confusion. Magnitude of force, magnitude of displacement, delta r, magnitude, and they are opposite, right? So cos 180 degree it is equal to change of kinetic energy. Finally it is 0. Initially here it was 4. Now solve. Force magnitude is 1 Newton. Displacement I am taking as x. Cos 180 degrees minus 1. So that means it is minus 4. That means x is equal to 4. That means from here to here 4 displacement. Already it was 4. So how much it is? Sorry, here it was x was 2. X was 2. X was 2. So 2 plus 4. 2 plus 4 you have to do, because this is 4 meter. That means finally x will be 6 meter. Clear? This is the answer. This is the answer. Tell me now your approach. No, no, no. That is not same. Potential energy graph slope changing means it will show how the force is changing. Force is some way positive direction, force is negative direction, but that doesn't help us to find where the velocity becomes zero, or the directional velocity doesn't help to find. That slope now, see, from here to 0 to 1, slope is positive. So if slope of this positive, so positive into negative, negative. So here is retardation. After that slope has changed. So this slope has changed. So force direction also change after this. So changing of the slope gives the changing of the force direction. Hmm. Okay. Anyone else? Any doubt in this question? Ask. Very fundamental question it is. Okay. Done. Then next. Let us move next. Hmm. Hmm. The point where motion reverses. So x is equal to 0, it is under retardation, but motion is happening. At x is equal to 1, it has speed in the same direction, 1 joule it has. But now the force is accelerating, so it will increase only. So kinetic energy has become 4 at 2 meter. At 2 meter, retardation happens. So after this, it will start decreasing, decreasing. So it will stop there, and after that, it will reverse will happen, just like when you throw a body. You throw a body, retardation happen, and then it returns back. That means acceleration happens. Are you understanding? So same thing will happen. It will stop temporary. Temporary stop will happen here because body is going. Retardation means its velocity becomes 0, but then it will start moving backward. Why? Because force is acting in this way. So force will stop it. As after that, force continues to act. So body will then push this way, this way, this way. It will go. You understanding this? Not seventh, sixth only. At x is equal to 6 only, velocity become stop means there only reverse na. Suppose you throw a body. Suppose the maximum height is 10 meter. At 10 meter it returns na, reverses na. That is the 10 meter where it is reversing. Are you understanding this? Yes. Here to here it is continuous only. Because from here to here it is going with some speed, velocity in this direction, but force is this way, constant force. So body is going to stop and then body is going to return back. That's what happens. Before that, what do you want to consider? Because before already you have taken Body is going from here to here, then body is also going from here to here, but body has not stopped or anywhere, it has not changed its direction. Why? Because initially it was already moving in this direction with 3 joule. Now retardation is happening, but still when it comes to 1 meter, it has still kinetic energy. That means still body is moving in same direction. Does not completely stop. It has stopped means velocity is reduced. From 3, it has become kinetic energy has become from 3 to 1. After that, force become in the same direction of velocity, so it start accelerating. So its speed increases, so kinetic energy increases up to 4 joule, from 1 joule to 4 joule. Now here you start applying a retarding force, but this retardation now remains fixed. After that, you don't have any accelerating force because graph is like that afterwards, right? After that, slope is not changing now. Slope is not changing afterwards. Hmm. Yes, because it is coming from this force. Force is minus d by dx, from here it is coming. Yeah. That you can say because this is more time from 2 to 7 it is going. So 2 to 7 somewhere it will stop after this. Okay. Mhm. Yeah, directly we can eliminate it. Okay, done. One question more, I think I will take it. Okay, then we will go next. Last question. That we will see tomorrow in the class. Okay. That critical velocities is. Mhm. Yeah. Any doubts? Any doubts you can ask the related. Right now we can focus on problems more advanced type of questions. This is all multi-concept questions. More than one concept. Okay. Yes, concept will be mixed. Yes, Raghavan. Tell me. What? No, no. Again, can you repeat question? U is equal to kinetic energy or total energy? Okay. U is potential energy is equal to total energy. Okay, then du by dx is equal to 0. Okay. So first see what is force. Force is minus du by dx. That means here force is 0. Force is 0. Force is not acting. Now let us take any point here. Body is moving. First of all, tell me body is moving or not moving at that position. Now, because total energy, which is supposed to be sum of kinetic plus potential, it is equal to potential. That means kinetic energy is 0. That means body is already at rest. Body is rest and net force is also 0. So force is 0 means it will maintain its state. But right now the state is 0 velocity, so it will maintain 0 velocity. It will maintain. It will remain at rest. At that rest. Hmm. Potential energy. Potential energy, one minute, uh, one by one noise I think coming. You can keep your mic mute if you are not using, because lot of noise is coming. Okay. uh, Otherwise you may use mic, that will be better because it will reduce the noise. Raghavan, you please check that. Okay. Okay. So see here, your question is potential energy. So here potential energy is total energy, and we do not know what is total energy. Suppose total energy is 5 joule, that means potential energy is 5 joule, right? So it may be at some height, body may be at some height, right? Maybe that is the potential energy. Wherever it may be down also, because some cases total energy can also be negative. Not that total energy can be negative also. So whatever that potential energy, that is equal to total energy, it is constant. Okay. Hmm. Then you have to take that whatever air is applying force, wind is applying, that force you take, then bodies will be moving. The force is applying, body will move. No, in real life also it can happen now, because net force is, suppose there is a body kept on earth. Let us say a body is kept on earth. Okay. So let us say it is at rest. So it has no kinetic energy. Kinetic energy 0. And potential energy, actually, the potential energy formula with respect to the center of the earth. The actual potential energy formula is minus Gm1 m2 by r. So there is some potential energy, okay, here. Even at the surface, although we may take 0 as a reference level, but there is some potential energy here, which is some constant. So that is same as the total energy, because kinetic energy is 0. So now at this position, if the total force is also 0, what is rest? It will remain at rest, right? It will not move unless there is external force act on it. If some external force will act, then the body will start moving, and then kinetic energy may change, potential energy may change, everything will change, right? Yes, Raghavan. Ah, yes. No, no, no. Why it is like that? Suppose if you throw a body upward, acceleration is constant, na? Gravity is always acting constant. But body has stopped because its instantaneous velocity has become 0. Acceleration is constant only. See, force is acting, na? Force is continuously acting on the body. Force has not stopped it. Okay. Force is changing its velocity continuously. At a particular moment, its velocity has become 0. Does not mean change of velocity is 0. Velocity value has become 0. So soon after, it will get some different velocity. Continuously, velocity change. Right? Hmm. There can be any amount of forces acting, but if a body rests, net force is 0. Net force are zeros. Friction will act only when the body has a tendency of motion, or if the body is actually moving. For example, here friction is not acting. Friction is not acting. Normal force are acting, mg is acting, mg and normal balancing. That is equilibrium. It will act, but if you take a body in vacuum and separate, there is no interaction with anything, then that is absolutely net force is 0, means any force is not acting. There is no force acting, so no need to calculate net force. because there is no interaction with that. Potential energy also will be zero. No interaction. Potential energy is due to interaction. Bodies are interacting, then only potential energy is there. Okay. No, no. Are you taking object as a particle or what are you taking? That also matters. Ball is a multi-particle. That means in a ball there are so many particles. These particles will apply electromagnetic forces on each other. Then even if you keep this ball outside in vacuum isolated state, then there will be electrostatic electromagnetic energies will be acting. So, but still total will be zero. Net force will be zero. But these are internal forces. They will cancel out. You have to see if the body is a point mass and that point mass is isolated. Isolated point mass will have no energy, zero energy. No problem. It will come by reading books, concepts. You have to develop that concept that you do. Let us take this question. It's a good question. One end of elastic cord is attached to a block of mass and other end is held, uh, keeping the cord relaxed and vertical. So there is a block is there and there is a person who is holding it. The person is holding with his finger. Okay, one end of elastic. This is elastic cord. Elastic cord, and a person is holding on this side, and the other end is connected with a block of mass m, keeping the cord relaxed and vertical. So cord is kept relaxed and vertical. It is relaxed length of the cord is relaxed length of the cord means the actual length of the cord is L, and there is a mark P at a height 0.8 L from the lower end. So from lower end there is a point P which is at a distance of 0. Like a rope on. Okay, relaxed length of a cord is length L and mark. There is a mark P. So total length of this cord is L. Total length of this string is L. Okay, there is a mark point. The upper end is sorry lower end, not from upper, from this from lower. Suppose this point upper point is point A, lower point is point B. So lower end means this distance. This distance is 0.8 L. 0.8 L. If the upper end is slowly raised, the block leaves the ground. Slowly you are keeping this point up and slowly you are moving it. Slowly, remember the word slowly. Slowly it is moved. Slowly moved. Zero velocity, but very, very slowly you are moving up, keeping everything in equilibrium. Slowly raised, the block leaves the ground. The block is initially on the ground. Block is initially on the ground, and slowly, as you are pulling it, it is going to leave the ground. When the mark P reaches the point where the upper end of the relaxed cord initially was. Suppose you move it up, okay, and note that this is a particular level. Let us keep this level. Now you have moved this cord up. Maybe this point A has come here, and this point P on the cord has come exactly at that level where previously this point A was there. It's like this. This point is P. This is the point. One more. Let me first complete that. When the mark P reaches the point P where the upper end is relaxed cord initially. So initially the elastic cord is relaxed. Relaxed. So assume that this cord is behaving like a spring because its cord means it is elastic. Elastic material is like a spring. Okay, it is like a spring. Block leaves the ground in the mark which is expression for the work done by force applied by the person. So person definitely is applying a force. Note that person is applying a force to move it. So question is work done by this man, that means work done by this force we need to calculate. Option is given as mgl by 6, option 16 mgl by 8, option C mgl by 5, option D mgl by 4. I will repeat the question first, then you can solve. So the question is that this is a cord, this cord is just like a spring you can consider. It's like a spring you can consider. And right now spring is relaxed means this spring has no elongation in it. The spring has no elongation in this. One end of the spring is connected to block, another end is held by this person. And it is vertical, right? It is not inclined, vertical, and then slowly this person starts pulling it. And there is a point on this cord or this spring which is from the bottom at a distance of 0.8 L. L is the total length of the spring. That is the natural length, you can say, relaxed length or natural length. Okay. So as you start slowly pulling it, what happens is that this point P on that spring or the cord is passing the same level, the topmost level it is going to pass. After some time it will pass. Okay, so it has passed like this. Right now, that point P is just crossing the level of A where A was previously there. Okay, now, the question is what is the work done by the applied force? Applied force means that man is applying some force F. What is the work done by the man in pulling this from this position to this position? That's the question. Clear? Are you clear about this question? Hmm. Clear. Yeah, yeah, time is infinite. Yes, yes, infinite time. Force does not depend on time. No, no, force does not depend on time. Force calculation, work done calculation depends on force and displacement. Net force is zero. That is what you have to take. Net force is zero, but man is applying some force. Net force is zero. Or kinetic energy is not changing. You can say that there is no change in kinetic energy. Net force is zero, right? But note that this is a spring, na? So spring will have a spring force also. Plastic material like a spring has a spring force. So there will be mg, and this rod or this spring has massless. You can assume that there is no mass of the spring, but a spring can apply spring force. So there will be a spring force, there will be gravitation force, and there is the force applied by the man. Okay, these are the three forces only. Why it is acting? See, suppose this is a spring, and as you are pulling it, the spring will pull this point A and block both upward, because the spring wants to come back to its normal position. The spring will pull this point A towards the normal position, B also towards. How spring force acts, that is little complicated, but you can think about it. Hmm. How? That is not the answer. Okay, so I'm going to leave this question for you to think about it. So let us take this question in the next class. Okay, you also think, I will also think. Then we can discuss the answer next class. Okay. Yes. God is moved, but God is also elongating. Point A has moved, but this cord or this spring is also elongating. Hmm. Hmm. And note that suppose this length is 0.8 L, it's not necessary that this length will also be 0.8 L. This length will be larger because it is not like a constant length, because it's like a spring. Length of this spring, yes, this part may become larger than 0.8 L. This length, which was 0.2 L, will become larger than 0.2 L. So this length, everything can change, right? So think about it. Okay. Then we see next class, right? Any other doubts if you have, you can ask. So can we wind up it? Okay, fine. So let us meet in the next class. Okay, bye bye.